Welcome to a new video on my channel where I try to do a product video of this Fnirsi 2D 15p 3-in-1 oscilloscope, multimeter and signal generator. The reason I'm saying I'm trying to do because, well, first of all, I'm not really an electronics engineer. I think a basic understanding how an oscilloscope works, but I haven't used an oscilloscope before. And I haven't even taken the time to, fully understand this unit or, watch a couple of videos how to use the oscilloscopes, mainly because this is going to be a Christmas present for myself. So I just wanted to unpack this, just play a little bit around with it, make this video, and then it's going to be, putting back to the box, and I'm not going to see this until Christmas. When you want to buy an oscilloscope, there is a wide range of different models that you can buy from. And if you want something really simple and really basic, there are these almost kit-like oscilloscopes that you can buy. And even from well-known brands, I think Rigol has an entry-level oscilloscope which is around like $300. So this is somewhere in between, sort of like halfway through. And the reason I picked this because it came to me on Facebook, because I was looking at Fnirsi's, I hope I pronounce the name correctly, radiation meter. But then I looked at the reviews and it was like a mixed reviews that they don't look at all or measure all radiations correctly. So I thought, no, okay, I don't really need the radiation meter. Actually, I do have one, which I'm not really using. So, I mean, it just looked really fancy. And I think this model also looked quite fancy, and this is why I like it. And also, if you have used oscilloscope, it probably is going to be a little bit difficult to understand as well, because it's a mix of a lot of different buttons, but also a touch screen, which, okay, may not be so unfamiliar nowadays, but maybe compared to an older oscilloscope, it is. And as you can see from the picture, I'm measuring a PWM signal, which I'm generating with an ESP 8266, which is running an ESP home firmware. And I haven't even calibrated the scope correctly because, you can see that the signals is not a nice square wave signal. So let's get into the meat of it. So I bought this mainly for the oscilloscope function, and I wanted a device where I can measure like a very simple home automation circuits, especially like ESP or maybe Arduino circuits, where it is not enough to measure with a multimeter, because on the multimeter you see a snapshot of the time. It cannot really do time resolution. You can't really see what's happening with the signal, or if the signal is really fast, the multimeter is not going to give you any data. So this is why I think like a basic oscilloscope is useful. And this one does, it has 100 megahertz bandwidth and 50 million samples per second, which is definitely not, an impressive spec. But the type of signals that I want to look at, like I want to look at PWM, or I want to look at a power supply just to see what the ripple voltage is, or if I want to see, for example, a digital input and I want to see signals, and maybe I want to see if there is a debounce, this device is going to do that without any issues. And for anything more complicated, it wouldn't really, work anyway. It also has a built-in multimeter, which is again a nice touch, because if you need to go out and you need to take one device, then this can do both of them. It also has a signal generator, which I'm absolutely not interested in. I don't think I will use it. And I had a quick look at the signal generator, and this seems to be very basic as well. I mean, it can generate the basic signals, but the amplitude is limited to 3 volts. You can't offset it. So again, maybe I'm going to use it once or twice, but I don't. That's definitely was something that I was looking for. So let me show you this test thing that I put together. So this is one of my light sensor board, which I used to test my LED lamps. So it has an I2C light sensor, and then it has a couple of outputs as well, because I wanted to do some additional testing. So I thought, why not just use this board to do some additional stuff? So if you look at my desktop, then I have this BH1750 luminance sensor. I have an output which is a digital output, and I have also an output which is a PWM output. So yeah, let's see what we can do with this guy. So what I have hooked up to is the PWM output. So now you can see that it is, measuring the PWM output. And if I change the slider on the ESP home, then the the PWM signal changes as well. And at least I can see, what is going on here. The resolution might be a little bit too small for you to see, but actually I see measurements here. So it shows me that it is a 1 kilohertz signal. So in ESP home, it is configured for 1 kilohertz. And it also shows me the duty cycle, so 37% at the moment. And voltage peak to peak, 3.3 volts. So the voltage max is 3.4 volts and the voltage minimum is 66 millivolts. So I mean, from this screen, I can, verify that, for example, a PWM signal is working correctly. And I have the usual things. So I can change the time base, and I can also change the resolution. And I also have this button to move the signal around. Obviously, this is a 2-channel scope. So if I have another measuring something else, I can put this on the top and I can put the other one on the bottom if I want to do something like that. But yeah, and I have this big knob here which changes the trigger. So if I move the time base back, then you can see that that's the trigger voltage which changes. And yeah, so you can see that it's a touch screen as well, so it does some of the functions on the touch. For example, changing the vertical and the horizontal resolution, which I don't think I do like that it does that. And on top of that, I mean, obviously it is triggering now, and it is triggering on channel 1 on the falling edge. So there is not an awful lot of triggers that you can do, rising edge, falling edge. Obviously it doesn't decode, so can't, trigger on data or anything like that. But, for a basic scope, I think it's fine. We have these various math functions as well if I want. So that's not something that I tried. So you can, calculate differences between channel 1 and channel 2. And then in the measurements, these are the various variables that you can also measure on. Like, well, at the moment I have the frequency, duty cycle, voltage peak to peak, Vmax and the Vmin, but you have some others that you can also put on the screen. I can also turn on the cursor. So for example, if I want to measure the time difference, so you can see that I can move this top one. You can lower the beeping, and you can also turn it off. So you use this button. It's a nice rotary encoder to move the cursors. So these are the 2 vertical cursors. Oops. And I can move the horizontal cursors as well. So now I can see, well, basically I would just put the cursors on the same values that the measurement also gives me, but you can see that the minimum and the maximum voltage, the time difference, and also it gives you the frequency as well. So if you have some more complicated signals, then you can measure time and you can also measure voltage as well. So I think that's actually nice. So you can see that you can, for example, call up some of these options, and then you use your finger to operate the touch screen, which is fine. And on the display, yeah, you can set up grids and that sort of stuff. And of course, in the channel menu, you can turn the channel on and off. You can also do change between AC and DC coupling and the probe. So the probe that it comes with is 1 times and 10 times probe. You can also quickly change the channels using the channel buttons. Yep. Okay, change channel 2 on as well. So I think it's triggering on channel 2 now. That's why it started running. Yep. And for example, if I change to a different output, so let me change to the, so this is the other output where I can just toggle. So obviously if I toggle, you can see the voltage changes, but if I reduce the time base, sorry, the other way around, then, you know, maybe I just want to see, you know, data that is coming in. So now I can, you know, do this. I can change the values on and off, and then the time base is set to, each resolution is 10 seconds. So it takes quite a long time for that data to go through the screen. So I can also visualize some very slow signals that way. And if I put it back to the PWM output, by the way, I want to say that the auto functionality works quite well. Yeah, so auto calibrates to the signal. Oh, it took the skew out. So, okay, that's the calibration done as well. I only tested a couple of different signals, and the auto was able to find the auto calibration always worked. It takes a couple of seconds, but then, you know, it worked just fine. So these are pretty much the basic functions. The other thing I wanted to show you is if I change this, let me move the probe around to the other side, because I put this on the 4th pin. Let me put the grounding back. And so this is the SDA pin. So if I change the trigger and I set the trigger to, let's say, no, I think falling edge, because that's also like an inverse trigger, and I do a single capture. So now we are waiting for something to happen, and I think I've configured the light sensor to take a measurement every 60 seconds. So we have to wait until it does and starts communicating on the serial bus, and then it should trigger on that signal. Okay, so I started playing around with the time base, but now you can see that it triggered on the I2C signal. The one thing I haven't really figured out, or actually two things, is how I can move the capture from left to right. And also, why is it that if I zoom out that I don't see any more data? So in this menu, I set the memory depth to 1 meg, which I think it should be more than enough to capture a little bit more, you know, more samples than that. But it seems that it's, you know, only capturing that much, what is limited in the screen based on the, you know, the time resolution you have for the x-axis. So that's something I probably need to go. I have looked at the documentation, but the documentation is really basic. So probably I have to look a couple of different videos, and I can, you know, move this up and down, but I don't know how to change to that marker on the top. So if I keep pressing this, nothing really happens. So I can't move the graph left to right. And that's how you would normally, if you do a single capture, that's how you go through the data that you have captured. I think there should be more memory than a single screen, so I should be able to go left and right on that screen. But this is something that I wouldn't be able to do with a multimeter again, because I need the sort of the resolution that an oscilloscope provides that to capture fast signals. But at least, for example, I should be able to tell that there is, you know, communication on the I2C bus. Maybe I could look at the clock signal as well, just to make sure that the clock signal has some real values. So probably this is also a way to, you know, debug either like serial ports or I2C ports, even though you don't really understand the messages that are going through because it doesn't decode the messages, but at least you can see that something is happening. So probably the, you know, if you have issues, the issue could be somewhere else. And I also want to show the multimeter functionality, which is, you know, it's nothing special, but again, you have one single device, and if you need to measure voltage, current, or something else as well, then at least you have that, and you don't have to take a separate device with you. So I have the probes connected on the top. I change to the oscilloscope menu, and for example, I'm not going to go through the whole settings, but let's say I'm going to measure voltage. So that's the 5-volt rail, 4.6 for some reason. Fine. So it shows you a little bit of graph as well, and you can change between, I mean, if you want to specify DC voltage, you want ohms, you want continuity meter. For some reason, I thought that the continuity meter works as well. It's not the fastest, to be honest, but these probes might be a little bit, I don't know, janky. You see, it works, but then I don't know why sometimes I will probably try with the different probes if it's a probe issue, but you can also measure diode, capacitor, and then, you know, current as well. There are some other connectors on the top for the current. So yeah, I mean, it's fine. It does the job. And you can also bring up the signal generator. And as I said, you can change the frequency, you can do all these different waves, but then on the amplitude is limited to 3 volts. So if I set it to 5, then it just defaults back to 3 volts. And these are the, I haven't even checked what's the maximum frequency that he can generate. But as I said, to be honest, I'm not really fussed about it, and I don't think we will, probably this is get used. You see that we have 2 inputs for the 2 channels, and there is a separate output for the signal generator. And that's it. The only other feature that I wanted to mention, that from the signals you can click on the save button and then it saves a picture. The resolution of this screen is not great. It's like 470 by 272, so that's the resolution of the BMP images that gets created. And if you want to get these images out, then you can call up the menu, you can do USB sharing, and then you can click it on, and you have a USB port on the back, which normally is for charging. But if you enable this menu, then it just becomes a mass storage device, and you can just download the images off from the device like it would be a pen drive. So I think this is the function that I could share about this device. There are some settings, menu and calibration here, which I haven't accessed, but the bulk of the feature is that much on the device. So I'm just going to show you the whole thing, and also some of the accessories that I got for it. And probably that should be all that I want to share as a review on this device. As I said, it's brand new. It was, it's at the, I think 159 USD at the moment. There were some coupon codes so you can get some money off. When I bought it, it was actually on pre-order in the early November, but I got it by the end of November. And well, today is the 1st of December, and I have this unit here for about a week, and I was able to spend some time to test around with it and, you know, play around with this simple ESP board. Okay, so let's go through the bits and pieces of this device. Well, it is still running at the moment, so it is frozen on that screen that I captured from the I2C bus. By the way, I haven't peeled off any of the screen protectors, so this is why you see these stickers everywhere. So it is a mobile unit. It is powered by battery, which is great because, well, of course, I mean, sometimes I need to take this sort of to the field, so you don't have to have a separate power supply or power bank or anything like that. I don't try to pretend that I really understand about reference voltages and stuff, but I think it also makes measuring mains voltages with the oscilloscope easy if it's not referenced to the ground, like it's not, you know, powered by the ground. Yeah, so that's definitely a plus. I haven't really measured what's the battery life is. I noticed that the charging is not a fast charging, so it takes a couple of hours to get the battery charged up. I think it has like a 5,000 milliamp hours battery, but probably I'm going to leave the details on the first screen. And I mean, you've already seen the buttons already. It doesn't have the same kind of, you know, sort of logical layout as most of the oscilloscopes, where the functions or the buttons are grouped based on functions. But yeah, I mean, it's a small unit. They had to fit all these buttons, but you have vertical and horizontal resolution, these dials here. This is the intensity where you move the buttons, and that's also how you move the cursors. There is a separate button for the trigger, which I think it's fine. I do like it because it's easy to just reach here and then change the trigger. And these are all rotary encoders, so they are nice. They have like an indent, and then I think, oh, these buttons you can push as well. So now the screen is gone. And this one you can push as well. I think you can push this one as well. So You can get a few more functions out by pushing those things. You have channel selectors and all the other buttons that I showed you up. It's nice that if it's rolling mode, then this is green, and if it's a single capture and stops the capture because of the trigger, it changes to red. You have two buttons here for single capture and auto. And so I use both of the buttons. So this is to calibrate the horizontal and the vertical resolution, and that was the single capture when I tested the I2C bus. You have the connections here for the multimeter functionality, and you also have the test calibrations, 1 kilohertz sine wave signal, typical stuff. And I already showed the channel 1, channel 2, and the generator. Well, these are two inputs and the outputs, and there is nothing else. So there are some rubber feet. You have these that you can fold out, so it sits like that, which is actually a really nice angle. Other than that, you can use it like that. And you have a USB on the back. You have a small vent. You also have these mountings if you want to mount it on an arm, and that's pretty much it. And you have a on-off button here on the side, and it takes like 5 seconds for this guy to boot and starts working. So getting this started is actually fairly quick. Let me show you all the accessories that you get for this device. You have probably seen the probe. I don't think it's a particularly complicated probe or high quality. The lead is very thin. This is nice and rubberized / silicone. So I quite like this. It doesn't get tangled. It doesn't pull you. And you have on the probe, you have a change for, oops, where is the focus? 1 times or 10 times. And I had it in 10 times. I must have moved it. And you also get the grounding clips that you can just put on, and then a crocodile clip for the ground. And of course you have the spring-loaded hook, but then just like with anything, you can remove it, and then you have this fine point probe as well. And of course this is the 2-channel device, so you get 2 probes. That's one of the probe, and the other probe is, completely identical, and you get a different colors just to distinguish them. I don't know why there is no yellow. Well, there is yellow and blue, but there is no yellow. Is that normal? I'm not sure. There is also a small screw to calibrate this is usually, I think it is used to calibrate the probe. So the probe usually, there is the calibration, which I haven't done yet. So I should do that as well. You get a separate set of probes for the multimeter functionality. It's just like, regular probes. So if you don't like it, you can replace this. Again, these feel a little bit stiffer than some of my others that I got from my Aneng multimeters, but still they are fine, and they have this removable tip if you need to reach into certain areas. Besides these, there is one more lead which ends in a B and C, and then it has 2 crocodile clips, so I would assume that you would use this for the signal generator. I'm not even sure if I'm going to unpack it, because as I said, I don't really care about the signal generator functionality. There is a USB cable, so USB-A to USB-C. Yeah, I have quite a few of those. What else? That's the second grounding lead, some papers, and there is a documentation which comes in 2 different languages. But again, it's fairly basic. It goes through, what buttons you have on the screen and what they do. There is some spec as well, which I already mentioned. Max input voltage is 800 watts. And the time base is 5 nanoseconds to 50 seconds, and the vertical sensitivity is 10 millivolts to 10 volts per division. Half of the documentation is in Chinese, the other half is in English. And that's pretty much it. I mean, to be honest, I'm really happy to have this device. I think I'm not claiming that I'm going to use the oscilloscope functionality a lot, but I have been in situations in the past where I was trying to do with something with a multimeter, and I realized that the multimeter is not a device for certain things. I mean, okay, you can measure voltages, but if you have signals, if you have fast signals, you have data, you want to understand a little bit more, you want to capture a very short transients, then you actually need an oscilloscope. And as I said, I could have gone for the very cheap, $20 do-it-yourself kits, but I do like the fact that it has so much of these buttons, and the touch screen is really easy to operate. It goes, very quickly, so it's a lot more user-friendly. And I was also considering one of the entry-level Rygals, which, I mean, if I remember correctly, it's like $300, but it's $300 in the US. I started looking around, and it gets a lot more expensive by the time I get it from here, from locally sellers, and the additional VAT and everything. So I thought that the amount of times I'm going to use this is the value that I was willing to pay, and I'm okay with the performance sacrifices that I got out of these, as opposed to like one of the name brands. So I think that's all going to be for today. Thanks for watching, and hopefully see you next one.